Okay, hello everyone. We are from Group 05, and today we're gonna present our final project of the fundamental analytics. Our team consists of me, myself. My name is Valdi Rehan Putarista.
My name is Raditya Putra.
My name is Diva Kararia Satya.
My name is Muhammad Najmar Raditya Kurnianto.
Okay, let's move on to the first section. The first section is the business understanding. From the data set we use, come from transaction record of a restaurant, business operating across 5 established types, such as food stall, cafe, casual dining, fine dining, and kopitiam. The core problem of the client face is the lack of the reliable demand forecasting system. As a result, the business frequently overorders, preset ingredients, and misallocates staff across different meals periods. Our project objective is to predict the target variable quality sold, that it is the number of the menu units sold per day, using the contextual information available before the service begins, such as selling price, restaurant types, meal period, promotion, weather condition, and special event. The model is considered a business success if it's one is accurate enough to reduce the ingredient over deriving and minimize the food waste, produce result the interpretable by restaurant manager without deep technical knowledge, and generalized across all the restaurant types and meal periods. Okay, move on to the section 2.
Okay, so thank you so much, Valdi, for the first section. So regarding the stage 2, which is the data understanding, the data set we use is a secondary data set, which containing the restaurant transaction records from 2024, and with a total of 13 columns. So here's the summary of the key variables. Okay, so here there are the quantity sold, the target variable, which is number of units sold per day, and there are actual selling price, which is the actual selling price that has a strongest inverse relationship with the target, and there are restaurant type, which is 5 restaurant establishment. The meal type, there are breakfast, lunch, and also dinner. Weather conditions, it is whether sunny, rainy, or cloudy, and has promotion and special event, which indicates binary indicators, which only state true or false. And last but not least is the key ingredient text, which is the comma separated list of key ingredients per menu item. So here is the data cleaning. So the data cleaning shows that there are 0 missing values, as you can see right here, which also includes 0 duplicate rows, and all categorical columns contain only their expected values with no anomalies. For outlier detection, here we use the IQR method because quantity sold exhibits a right skewed distribution, where skewness is more than 0.5. And the outliers in quantity sold itself were not removed. And as these extreme values reflect valid business realities, food stall items with low prices uh, we genuinely sell hundreds of units per day, compared to fine dining, which average around 36 units per day. For initial exploration, we conduct distribution and correlation analysis. So the key findings are, so yeah, the key findings is that the actual selling price has the strongest negative correlation, with quantity sold for about minus 0.54, followed by typical ingredient costs, which about minus 0.53, and the observed market price, which is minus 0.46, and last is the quantity sold for about 1. and these are indicating significant multicollinearity. So last but not least, also these findings directly inform our modeling decision, which is tree-based models such as random forest and also XGBoost are better suited for this dataset than linear regression, as they handle multicollinearity naturally through their split-based mechanism, and also because our data consists of discrete data types. Okay, so next, Najma will explain the data preparation stage. Thank you.
Okay, thank you. So at this stage, we prepared the data to be ready for model. Here are the steps that we carried out. First, cleaning. We applied Drapna as a precautionary step, even though no missing values were found. The date column was also dropped as it is not a predictive feature. Second, label encoding. The Boolean columns has promotion and special event were converted to integer values 0 and 1 using PD factorize, and their data types were confirmed as integer. Third, handling zeros and duplicates. No zero values were found in the numerical columns, and no duplicate rows were detected, so no further action was required. For scaling, 3 numerical columns, which is typical ingredient cost, observed market price, and actual selling price, were standardized using standard scaler, resulting in mean to 0 and standard deviation to 1. This is important because some of the models we tested are distance-based. Fifth, feature selection. We tested 3 feature selection methods. First is the filter method. We use Pearson correlation for numerical variables and Kramer's phi for categorical variables against quantity sold. The results are all 3 pricing variables, and the top 5 categorical features were selected as most relevant. The second method is embedded method. We use feature importance from a random forest model. The top features are actual selling price, typical ingredient cost, observed market price, restaurant type, and has promotion. The third method is wrapper method, which we use RFE or recursive feature elimination with linear regression. And then we select the top 10 features, predominantly the pricing variables and categorical dummy columns. From the convergence of all 3 methods, the final feature set selected for modeling consists of actual selling price, typical ingredient cost, observed market price, has promotion, special event, plus 1 hot encoded dummies for restaurant type, meal type, and weather condition. And the result is a total of 28 features. And next section will be explained by Divakara.
Okay, thank you, Najma. So in the modeling stage, we trained and compared 3 regression algorithms. All models were tuned using grid search CV with 5-fold cross-validation to ensure good generalization. The data was split 80% training and 20% testing using random state of 42 for reproducibility. And here you can see that for the first model, the parameters tuned are numbers of neighbors, which are 3, 5, and 7, weights, which are uniform and distance, metrics, which is Euclidean, Manhattan, and Minkowski, with best parameters of metric is Manhattan, number of neighbors is 7, weights is distance. And for the second model with the MLP regressor, the parameters tuned are hidden layer sizes, which is 64 and 128 neurons. Activation is ReLU. Learning rate in it is 0.001, and the best parameters for hidden layers is 128. The activation is ReLU. And for the third model, yes, the SVR parameters tuned are kernel, which is RBF and linear. The C is 1 and 10, and the epsilon is 0.1. And for the best parameters is C equals 10 and kernel equals RBF. Scroll down, please. Okay. And for the model comparison, for the first model, we have an R-square score of 0.7182 and the RMSE of 113.86 and the MAE of 85.24. For the second model of MLP regressor, the R-square score is 0.7161, the RMSE of 114.29, and the MAE of 84.14. For the third model, the SVR, the R-square score is 0.6533, the RMSE of 126.3, and the MAE of 92.95. Here, for the first model, the KNN performs well because restaurants and menu items with similar feature values such as price range, restaurant types, and meal period do tend to exhibit similar sales volume patterns. For the second model, it is nearly identical to the first model, which is the KNN, with a note of convergence warning was observed, meaning that the model could improve further if max iter is increased to 1000. And for the third model, the SVR showed the weakest performance among the three, likely because the high dimensionality of the feature set limits the effectiveness of the RBF kernel. And for the recommendation, the KNN regressor is selected as the primary model as it achieved the highest R-square and the lowest RMSE, with the most interpretable prediction mechanism among the three. All three models explain approximately 65 to 72% of the variance in daily quantity sold, which is sufficient to support inventory planning and staff scheduling decisions.
Okay, so thank you all for listening. That is all from us, Group 5. Thank you.